Today we start dimensional analysis. See, the unit of a physical quantity can be written in different ways. For example, velocity you can measure in meter per second, you can measure in kilometer per hour, you can measure in feet per second. So what is the unit of velocity? That is unit of length by unit of time. In every case, we divide the unit of length by unit of time. Meter is the unit of length, second is the unit of time. So you can say velocity is equal to what it is? It is unit of velocity equal to unit of length divided by unit of time. So if the unit of length is in meter, unit of time in second, then the unit of velocity is meter per second. If the unit of length is kilometer, unit of time is hour, then the unit of velocity is kilometer per hour. Now what is dimensions? The dimensions of a physical quantity are the powers to which the fundamental units are raised in order to obtain the derived unit of that quantity. You know, length, time, these all are fundamental quantities. While writing the dimensional formula, mass is denoted by m, length is denoted by L, and time is denoted by T. So, what is the dimensional formula of velocity? You can say length by time. For velocity, the dimensional formula is length by time, that is L t to the power minus 1 or m naught L1 t to the power minus 1. So, m naught L1 t to the power minus 1 is the dimensional formula of velocity, and you can say velocity has 0 dimension in mass, 1 dimension in length, and minus 1 dimension in time. Actually, dimensions are these powers. Now, a general formula to write the dimensional equation or dimensional formula of any physical quantity is m power a, L power b, T power c. It can be some other quantity. If current is there, we use I, and generally m, L, T, but some other quantities may also come. Here the power of m is a, power of length is b, power of time is c. So a is the dimension of mass, b is the dimension of length, c is the dimension of time. Now let us consider some examples. For example, area. Let us consider area of a rectangle. Area of a rectangle is length into breadth. So length into breadth means length into breadth. Breadth is also a length, breadth is also a distance. So it is L power 2. So you can say m naught L2 T naught. So we can say that area has 0 dimension in mass, 2 dimension in length, and 0 dimension in time. Secondly, suppose volume. We are talking about the volume of a cuboid. Volume of a cuboid is length into breadth into height. So it is L into L into L, that is L cube. So the dimensional formula is m naught L cube T naught. Now if you know this dimensional formula, then you can get its unit. It will be meter square, because the unit of length is meter in SI system. The SI unit of volume, it can be meter cube. It is meter cube. So knowing the dimensional formula, you can find out the SI unit or unit of any system. In any system, you can find out the unit of that physical quantity. Now let us consider density. What is density? Density equal to mass divided by volume. Density equal to mass by volume. Mass is m and volume just now you have seen it is L3. L3. So it is m1 L minus 3 T0. So we can say that the dimensional formula of density is m1 L minus 3 T0. So we can say density has 1 dimension in mass, minus 3 dimension in length and 0 dimension in time. Next, let us see acceleration. Acceleration, it is actually change in velocity divided by time. Change in velocity divided by time. We know that the dimensional formula of velocity is Lt to the power minus 1. So the change in velocity will have dimension Lt to the power minus 1. So it is Lt to the power minus 1 by t, that is Lt to the power minus 2, or you can say m naught L1 t to the power minus 2. This is the dimensional formula of acceleration. So we can say acceleration has 0 dimension in mass, 1 dimension in length and minus 2 dimension in time. Let us see force. Force, all of you know, force equal to mass into acceleration. So what is the dimensional formula for mass? It is m1. And just now you have seen for acceleration it is L1 t minus 2. So we can say for force the dimensional formula is m1 L1 t minus 2. So we can say force has 1 dimension in mass, 1 dimension in length and minus 2 dimension in time.